Hey, what's up, guys? So today I'm going to introduce you to this Blender add-on package tool to see how to use this framework to improve your add-on development experience. So I suppose that you have already have some basic concept about how developing a Blender add-on or extension looks like. You can find the information on Blender official website. But today I'm going to just focus on the benefit provided by this framework and how to pick it up to make your add-on development experience more enjoyable. Of course, to use this framework, you need to first clone it and open it on your local machine. Here I already do this. I cloned this repository and I opened it with Python, which is my favorite Python development IDE. Of course, you can use VS Code, you can use whatever you like. This framework does not have any requirements on the IDE you need to use. You can even use Notebook. You can even use Notepad if you like. Okay. After downloading the framework you need to specify two things basically. One is the add-on you need to develop or test or package. Here it is by default the simple add-on, which is the add-on provided by our framework by default. And the second thing is the Blender executable path, the path to your Blender executable. So if you are using Windows, it should be something like this, blender.exe. If you are using Linux, it might be look like something like this. For Mac OS user, your executable should end with .app. Okay. Suppose you have set up everything. You want to test this sample add-on. Yeah, let me do this. So I'm going to show you the first feature of our framework, which is the hot swap. So when you test your add-on, you can see our add-on has already been installed inside our Blender. This is the example add-on panels of this add-on. And on the right-hand side, you can see the code of it. So basically, we have two panels here. One is this example add-on sidebar. So suppose I want to make a change to my UI. For example, I just comment out these 3 lines and hit Control Save. And you can immediately see the update of your add-on inside Blender. Right? So let me create something. Oops. So look at this. I just did a typo here, and you can see immediately the error is being reported, and you can click on the link to figure out where the typo is. Okay, so let me correct it. Okay, now it go back to normal state. So this is an example operator of the sample add-on, which just scale up your active object by several times. Now let's look at the code for it. Suppose we want to make a change to this operator. For example, I want to also report something, and let's save it, and you should be able to see add-on updated here, right? And now, when you click on the button, you will immediately see the change being made to the add-on. So these features will help you develop and test your add-on in real time. Alright, the second functions of this add-on is it can package your add-on very smartly. So how to understand that? For example, this framework is for you to develop not only one add-on, but you can develop several add-ons at the same time. And imagine that when you are developing a lot of add-ons, you must have something that can be reused among these add-ons, right? You have some reusable functions, you have some reusable components, classes, etc., etc. You want to use it in different add-ons. How would you manage the code base? With our framework, it should be very easy. So for example, you can use Python import to import some function from some modulars from other directory. So here we are working on sample add-on. We can create another directory. We can create another Python modular, for example, Python package. For example, tools. Okay, and I can add some Python file inside. For example, tools. I can define new functions. Maybe my tool. Okay, so for demonstration, I will just do some very simple things here. You can also place this. You can also put this under common also, or whatever directory you like. And then in your sample add-on, for example, in operators, I can import it. I can use absolute import or relative import. Although you might learn that when developing Blender extensions, you have to use relative import. But a feature of this framework is it will automatically convert your absolute import to relative import when package your add-on. So here I will just use absolute import from addons.tools.to import my tool. Okay, so and here I want to report my tool. Okay, this is a string, right? Okay, let's save it and test it, and you can see now it becomes my tools, right? So I can also update here my tool 3, and it becomes my tool 3, right? Okay, so let's stop our testing. And now I want to create a zip file from my code, right? Because I want my user to be able to install it by install the zip file. So let's find the release file here, the release.py, and we can just run it. And you will see it prints out the release path, the path to the release package. So we can find it here. I already have a lot of add-ons here, so we need to figure out which one is the one we just released. So apparently it is this one. So we can open it to see the structure of the add-on. And you will see sample add-on, tools, they are all here. And let's open the common files. You can see some files that is used by our framework. Now, suppose I remove this import. I don't import it anymore. And I will release it again. Okay, so let's look at the structure again. And this time, you can notice that the entire tool directory goes away. Because our framework is very smart, it can automatically detect all the dependency you have used within your add-on, within your target add-on. And it will select which files to be included in your final zip file so that you can build a zip file that only contains necessary files for your add-on. This is called dependency detections, and we are actually using deep first search algorithm to detect all possible dependency from your target add-on. Yeah. So this is another benefit of our framework. And the third thing is that now we are developing an add-on, a legacy add-on, right? So if you understand the difference between legacy add-on and Blender extensions, you will know that this add-on here is actually, although it has this toml file, this is because we put it under our add-on directory. Although it has this, it is still a Blender add-on, a legacy Blender add-on. If you don't believe in that, you can install it. You can install it with Blender 4.2, and you can drag this zip file into it, and it will show you that this is a legacy add-on instead of an extension, right? So what if you want to develop an extension? Very, very easy. I will show you. You just need to make a one-line change in your main.py, which is here. It's extension, right? It is set to false. So now I will set it to true, and then I release it again. Okay, so now you can see the add-on is released as sample add-on / extension. Okay, now what if I try to install it? So it will show you this is no longer a legacy add-on, it is an extension, and it is here, right? So if you go to preference, you search for sample add-on, here it says it is an extension. Yes, so you just need to do one line of change to make your add-on into an extension. Remember, we are using absolute import somewhere in our add-on, right? Oh, sorry, I forgot I didn't comment it. Let me do it again. Okay, release it. Now let's look at the corresponding files in the add-on, which is the add-on operators. And as you can see, we have the framework. When package your add-on, it will automatically convert your absolute import into relative import, something like this. So it is very convenient, and you don't need to care about how to convert your existing absolute import into relative import. You can use whatever you like. Okay, now let's talk about third-party library. So as we all know, Blender 4.2 introduced the extension in which you can include your own wheels files in your extension. And for example, the pillows library. This is an example from the Blender official website. Now let me demonstrate how to do that in our framework. So our framework does have this wheels directory for you to maintain your wheels to be used in your add-on. Now let me open the terminal here. Okay, suppose I want to use the pillows. I first need to download it with this command line. You need to specify the Python version, your platform, etc. So here I will just run this command to show you how to do this. So I have downloaded and put it into the wheels folder here, right? So in my extensions, I need to declare the wheels file here. For example, yeah, in the toml file, we have these options for us to declare our dependency. So remember, you just need to write it here, right? Like this. And then you should be able to use that PIL. So notice that when developing, the Python interpreter used by your IDE may not have the PIL installed. To make it easy for you to debug or to develop, you can of course install it from your IDE. But here, let me just show you that how the package tool will handle this views file for you. So let me do something like yeah. So here I will just print out the file attribute of the PIL library every time when I invoke the operator, right? And I can release it. So let's look at the package generated by the framework now. And you should be able to see that it creates a views folder in your add-on, and which includes the views file you want. And now if you install this, now let me install it again, right? If you install this to your Blender, let me restart my Blender to make sure the add-on is updated. Okay, so let me execute the operator, and you will see that it prints out the file attribute of PIL of the pillows. As you can see here, right? It is PIL. So that's how the views works in our framework. To make it easy for you to test your add-on without package your add-on every time, you can do this. Let me show you. So let me uninstall my extension first. Okay, so if we test it directly, you will see some error here because it does not have PIL. You cannot import it. So what you can do is you can find out the Blender Python interpreter and use it as your project, as your IDE's Python interpreter. For example, I'm using Blender 4.0 in this case, so it is let me find my Blender executable on my local machine. It should be somewhere here, bin this Python, right? So of course you can use pip. You can use pip to install the pillow by yourself, or you can like specify the Python interpreter and find out the one we are using to test our Blender. Select existing. Okay, it should be existing one, right? Okay, so here I can just install pillows. Yeah, here, right here. Let me install my package. Remember, you are only install it on your local machine for your Blender that is on your local machine. Even it is runnable on your local machine, it doesn't mean that your add-on users have this library. But this is just for you to test your add-on easily. You still need to include the views for the pillows in your extension. Declare it in your toml file, right? Okay, let me run the test again. So this time we should be able to test it. Okay, let me create something here so that I can invoke my operator. And now you can see the path to the pillow package can be printed out, can be reported properly. Okay, so this is the tricks how to test third-party library with our add-on and how to include that in our final build. Okay, we have already covered all framework features. Now let's talk about the sample add-on. The sample add-on also provides some optional feature that you can use for your add-on. For example, the auto class loader. What does that mean? So let me do a demonstration here. Okay. So let's start testing our add-on first. Here we have two panels, right? So in the panel class, we have two panels, 1 and 2. So let's duplicate it. I want to create a third panel, panel 3. Third panel, right? So, and save it. And you will see immediately the third panel appears here. But you might be surprised because we didn't even register that class. We just declared it here. Why it goes directly into Blender without we call the registering functions from bpy.utils? This is because the sample add-on adopts a mechanism called auto class loading. Where it is? It is in the common folder. We have these auto load modulars here. And when you look at our sample add-ons init file, you will see something like this. Autoload.init, autoload.register. So basically this modular will scan your add-ons, scan every modular inside your add-ons. By modulars, I mean package that has an init files. All these package that has an init files will be treated as a Python package, and it will be within our autoloader's scanning scope. So as long as you are declaring a Blender class in these modulars, the autoloader modular will automatically pick it up and register it for you. So you don't need to write it again and again. I see a lot of existing add-ons. They maintain a very long list of all the Blender class they used inside their add-ons, and every time when they need to add a new class into their add-on, they need to remember to add that class also to the list. So if your add-on becomes very complicated, maintaining this list can be a problem by itself. That's why we have provided this auto load mechanism in our sample add-on for you to use. Of course, you don't necessarily need to use it. For example, if your add-on is really simple, for example, you can just create an add-on like simple. An add-on might consist of one single file, as you know, right? You only need to specify Blender info. You just need to define the register functions and unregistered functions. That makes it an add-on already. The framework allows you to develop such add-on as well. So you don't need to follow the sample add-on structure. You can define your add-on structure whatever you like, but if you want to use the auto load mechanism, you can take a reference to the sample add-on, use this auto load module. And another thing that the sample add-on take cares for you is the internationalization. So basically you can find an IATM folder here. We have a dictionary here. If you want to support another language, you can maintain your dictionary here. V allows you to provide just key and value, so you don't need to write, you don't need to follow Blender's tradition, which I feel like is a little bit tedious. So I did some pre-process on the dictionary so that it can support something like this. You don't need to use this tuple here. Okay. Of course, there are some other small features like registration order, which is a way that you can make sure the class is registered in certain order. Like the 1 will be 0 will be registered first, 1 will be registered after zeros. Because in some case, suppose you are doing UI development, the default order of your panel is determined by their registration order. So in those cases, you might need to specify the order of registrations. But usually you don't need to do that. The framework will automatically analyze the dependency relationship between Blender class and register them according to the dependency relationship. So usually that's enough. But if you have multiple panels, you want to make sure they appears in a certain order, then you can use this decorator in Python to specify the order of registration. And let me see what else. Okay, so to develop an add-on in our framework, because all these add-ons have some submodules, so when you are using add-on preference, you need to use this add-on name in the config file to define the Blender ID name for your preference. This add-on name is defined in a way that is compatible for both extension and add-on, which is based on this package attributes. Basically, you can see the definition here. For an extension, it will use the first 3 items of the package. For a traditional legacy Blender add-on, it will just use the first item from the package attribute. Okay, this follows the tradition and makes sure the compatibility, makes sure your add-on is compatible in both Blender 4.2 above and the 4.2 below, right? So yeah, that's something you need to take care when using our framework. Okay, there are some other small features you might want to use. For example, you can declare property like this. So if you have some experience of defining property for your add-on, you might know that you always need to install it. You always need to add it in register method and remove it in the unregistered method, right? So you always need to write it twice. So our framework provides a cleaner way to define such property. You can just declare them inside this map like this. Suppose you want to add this property to bpy.types.scene, which is of this type. You just need to maintain it in this map, and our add-on will add properties for you, and it will also remove the properties for you. So this is also an optional feature you can choose to use. We provide APIs for you to realize this. Okay, I think that's all for today. Thank you very much. Hope you enjoy developing Blender extension and add-on with our framework. See you.